Hello, I'm back. I am going to talk a little bit about design. It's kind of not something that people like to talk about a whole lot. Um, and I should clarify immediately that when I say design, I don't mean graphic design. I'm talking about system design. So something that's a level below software architecture, but still is of relevance to programming. Um, so when you're dealing with software architecture, which I'm not really going to go into, um, that will be describing the very coarse setup of systems, how objects interact, how they um, how they communicate with each other, what major objects represent, um, so that somebody has a single overview of how the system should look for the whole system, whatever the whole system is. Um, and below that level, you still have to do design work. Now, mostly you do this in your head as you go when it's something simple. That's no problem. So, if you have to add um, add some input from a user, for example, um, you you may start with, I want to add some input from a user. You may think, where should I put this input? As in, where should I put the result of this? And you may think, how do I capture this? And then you can just implement it if it's in, if it's in a relatively simple case. So a lot of the time, you don't really need to worry about it, but sometimes you do. And generally speaking, the situations where you need to be thinking about it are the situations where it's kind of complicated, and where you perhaps start by thinking you don't need to do anything, because that should be your little warning sign that you haven't thought this through properly, or that somebody hasn't thought it through. Because obviously, it's not necessarily you personally who has missed that particular element. So, in essence, like with most work that has um, some kind of deterministic aspect to it, the time that you put into um, pre-visualizing what you're going to do tends to come back multifold later. So if you prepare well, you can spend less time dealing with it, and you can spend less time dealing with the consequences of the stuff that you got wrong. And that's the real mess that you get at the end. This is the thing that constantly in complex systems uh, is a nightmare, and that's my phone not being on silent. Um, yes, on complex systems, it's a nightmare, and you you need to have a good sense of what it is that's going on, and everybody kind of needs to have some agreement on what that sense is. In order to produce something that isn't a complicated mess. Because every time you produce something that's a complicated mess, people will come back to it later on and they will say, I can't understand this. So I'm just going to hammer in a little bit of extra complicated mess, and you get even more complicated mess. Um, and it just gets worse and worse and worse. And you get to the point where you need to fix an existing bug, or where you need to make something make a change which exists at multiple levels, and you can no longer tell how everything works, how everything interacts, and you actually need to stop and look through and examine each and every chunk of it. So that's a nightmare. You don't want to get into that situation, and the way you avoid that situation in general is by having a strong design from the outset. Here I fucked up. I haven't got a strong design. I've got a kind of a bit of a mess. So you will have noticed. Well, you might have noticed. I mean, I'm not going to go back and watch my old stuff, but probably I've gone into this project before. So this is a JavaScript project which actually relates to parsing PHP, because That's the thing. There's a relative lack of uh, good quality static PHP parsers. And that kind of creates a big problem if you are writing PHP as it is, because PHP will syntactically let you do quite a lot of things, and then it'll just break at runtime. And that's a nightmare. Breaking at runtime, always the thing you want to avoid. If you can't completely avoid it, you want to break at runtime at the first available opportunity. You want it to break the second it starts running for everybody, because if it does that, it will break in testing. And if it breaks in testing, you can fix it before anybody actually gets to it. And obviously, if it breaks before testing, if it breaks during development, that's so much better, because you don't have to even send it to the testers. You can immediately tell there and then you've just written a line, the line broke the build, fix the line. Very simple. So yeah, PHP, the way it works is kind of oppositional to having good quality software. And for that reason, this is kind of a relevant thing to do. So you can see up in the title bar, I've called this project PHP Semantic Parser, which is kind of, it's kind of messing about a bit. It's not semantic, is it? But what I'm trying to do here is have something which will parse the PHP concept of an abstract syntax tree, because that has one nowadays. And rather than keeping the syntax tree around, it will throw that away as it goes, essentially, and instead it will produce a representation of what the end results are of it. In particular, the things which are of relevance to this are return values from functions and input values. And so, I'll see if I can. I'll have a quick look at my tests, because my tests might be interesting. What I want to see specifically is look at this indentation. I should just cry over that. So specifically, I'm looking for. No, I don't have any. So I was looking for properties. So the reason I mentioned those, they're a classic example of where there is a problem with PHP in terms of determining what it does. Because a fairly common pattern in PHP is this, and you've got private, if only I could type, value. It doesn't have a default. I'm going to say it's not set in the constructor, and you've got public function set foo, whatever. So then this foo is v. We return this because I'm just doing influence style. That's what that is. And you have further up, ideally, public function get foo, return this foo. So this is kind of a classic problem in terms of dealing with particularly type inference. That's the thing I'm mainly concerned with here. So if you can see a call somewhere to foo dash greater, that's all it would be. It'll be whatever the variable is. Right, there you go. I'm gonna instantiate it so there's no confusion. Right. So if you see a call to $f dash greater than get foo somewhere in code, you don't know what that type is. And in fact, you would only know what that type is if you had if you knew what $v is coming into set foo. You can't know what $v is coming into set foo unless you can see every single caller of set foo. And even then, of course, you can't know what future callers will do. You can't know what it will do kind of for consistency reasons. So sometimes you can deal with that if it's in extremely limited scopes. If you have a call to set foo and then immediately a call to get foo, I mean, yes, it'll be the same value, whatever was put in there. hooray. Um, but yeah, otherwise it's just a complete mess. You can't tell what's going on. So you want to be able to deal with that as far as you can, and you want to be able to deal with these kinds of struggles. So a thing, for example, maybe at some point there'll be support for is perhaps inferring that git foo and set foo are specifically the fluent pattern and recognizing them as being equivalent to property assignments. In which case you could immediately say the types of these two are the same. And in fact, it's possible that, let's just undo that, it's possible that it may be possible to implement this as a nominally generic, nominally generic class. I can't remember how to do generic syntax in any language that's particularly relevant to this, but I think it's probably in most languages it would be like that, and so it might be possible to take that kind of syntax and internally say that convert these essentially to that kind of structure, so that you can see that there is an inherent type to whatever the class is, and that type will be shared between the setter and getter. But that's also quite nightmarish. In reality, in fact, what I would actually do is I would just treat this as mixed. Even so, it certainly is a default state. I would say this is just, I don't know, any value, and in general, that's the easiest thing to do. So I've already got stuff that will parse most common PHP stuff. I mean, I can show you. So you saw what the example PHP looked like, and in fact, I do have a test script which, well, okay, so this loads a couple of them. It loads trivial and simple, and it successfully parses them. In fact, this does successfully parse quite a lot more than that. I'm going to say I'm annoyed by that red squiggly underline because, obviously it's strictly correct. There might be no nodes. They might be undefined. I will have to deal with that. So, at the moment, when I parse a class, I'm actually just treating it like it's an AST. I'm just loading up some nodes. That's all I'm doing. So that does not do me any good. That's not the result I want to have. That's like an intermediate state that may be somewhat beneficial. And yeah, what I want to have internally is not a list of nodes, but rather a list of symbols, a list of namespace components. And that's why I've created a couple of new empty classes to put that stuff into. And this is the point at which I need to do some thinking. This is not the time to be doing typing. I'm not a typist, I'm a thinker. So I'm going to kind of talk through what my reasoning is here and what the end representation is that I'm looking for. And when I've done a bit of talking through that, when I've kind of come to like a reasonable conclusion, that's the point I will think about starting to type. So, well, I mean, I'll probably be like moving around between files a bit while doing this, but I'm probably not going to be typing very much. So, in this case, we've got a class. So the class at an outer level is actually fairly simple. So I don't want to look class body. I want to look at class. So yes, so this has some very simple properties. These are exactly the same whether it's semantic or not, um, because yes, they're the same at runtime as they are at compile time. We with at runtime we also just need to know true or false, whether it's abstract or rather at yes, I suppose at actual object linkage time, essentially. We want to know whether it's abstract, and we also want to know whether it's final. If you're not familiar with that concept, final means that you've got a class which is never going to have subclasses unless all they do is implement methods which are already abstract, which is it's kind of a mouthful, but it just means that you're saying that all of the implementations that you've already provided are not permitted to be overwritten. It is a thing that is sometimes useful. Mostly, it's useful to stop people who are perhaps trying to go around an overly complicated route and make them think, wait, maybe there is a simpler way to do it. It is actually a bit of a so uh, right. So abstract and final, in a sense, do opposite things. So abstract says give me subclasses. Final says don't give me subclasses, in essence, although in fact, actually, you can still subclass a final class, but you can't change anything in it. So I believe you can have an abstract final class, as strange as that may be. Um, yes, what a strange concept that is. And actually, from the perspective of the whole class, a class is final when nothing may be added to it. So it's more interesting, really, from the perspective of a symbol, because a symbol is final when it can't be replaced. Um, that's essentially the difference. And obviously, implements is a list of interfaces that this is declared as supporting. This is something which is not of relevance mostly. So mostly past the initial syntax check, the implements value is less relevant because you're past the point of actually asserting that you have all of those things. You're now at the point of uh, either having them or not having them. But it is of some relevance to type checking because those types do exist, and the fact that this class is compliant with the type is relevant to cases where you are passing something in, which does support the type, and it's also relevant the other way around. So if you're passing a function which implements foo implementation, um, so if the foo implementation is the argument type and you're passing a foo in which supports foo implementation, then you know that that is acceptable. That is a thing that will work. But if you also have the reverse, so inside a method that takes an argument which is of type foo implementation, you know that it's possible that instance of foo class may be true. Um, but so you wouldn't want to accept passing something in to another method which requires foo class, because you would say, no, that's a compile failure. But you would want to accept using instance of for that purpose, which is another reason why semantic parsing is a relevant concept here. So yes, so abstract and final, both concepts that are the same in semantic version. Implements is again absolutely of relevance. So this should be a list of strings. If it's not a list of strings, then maybe it's a list of the actual interfaces. I don't know. not off the top of my head. Realistically, this might be something which, yes, I mean, realistically, this should be a list of strings, I think, because we would want to be able to do that lookup separately, even if the underlying values are still used, because it will still be useful in terms of looking at the linkage to work out what that is. And it's completely possible that the thing that is implemented there is not a thing that is found, although we should just warn if that's the case. So this is the basics of this class system. Yes, I mean, I kind of didn't need to have this exactly as it is, so I don't know why I'm doing implements twice. So an earlier version of this was a lot more complicated, yeah. So previously parser any class had a lot more in it. Now it doesn't. So this is kind of legacy code as it currently stands. I'll probably leave it as an empty. As well, actually no, I wouldn't leave this as an empty class. I'll probably just remove implements from this. As well as this, you do have extends as a concept to indicate the superclass. And let's have a look. Right, so that does set extends. So I've made a bit of a mess of this by not pre-declaring it. This is one of the problems if you're writing JavaScript rather than TypeScript. You can't actually say in the current form, this is a property. You need to actually assign them to something. So yes, in this particular case, it'll be a string, basically. And we've got a bunch of implemences, which, yes, is an array of strings. That's what I wanted it to be. And of course, you've got name, which is a string again. And all of those are things which are relevant to the semantic representation. So, yay, I want those to stay roughly as they are. But over in the class body, if I just, actually, I can just find it there. Yeah, there you go. Parser class body. So in here, I've got a list of nodes. You can tell I was feeling a bit lazy when this happened, because why would you use nodes? Why would you use this kind of a generic thing? In fact, symbol is probably the term I would use for this. So these are a list of, yes, these are a list of symbols in the namespace. Oh, okay. Yes, in fact, actually, it's not just symbols. It's also use traits, which import symbols, which is, yes, kind of their own special thing. So this is a somewhat interesting case because, so in terms of the semantics of this, ideally, I want to be following those use directives as early as possible. So a use directive inside a PHP class is mixin. It's in other words another file that contains a chunk of code that will appear in this one, just to avoid copy and paste behaviors. So one trait will actually map to a bunch of class symbols. So possibly that may be a thing which I want to change in future. And I think at an early point, this will be something that's not, that's not perhaps directly representative. So what I might be saying is that nodes is not a list of, well, it won't be nodes, it'll be something else. So symbols, I might say, well, symbols can be, rather than a list of, rather than a single list of things, it can be a promise of a list of things, where I'm separately retaining the trait information, specifically the names of the traits and how they're handled, and retaining the actual class symbols. So in other words, what I would probably have is a getter on this, which is be like get symbols, and this have this return returns promise, and I'll just pretend it would be a parser class symbol, but it won't be this good, it would be something else. Yeah, so it would have something like this, return you promise. This is probably going to complain, but that'll be fine. Promise. Yeah, it is complaining. But so I would have something like this. Actually, can I do async get? No, I can't. That's because you don't like me. You don't like me. It's funny, I should be able to do an async getter, because I should be able to express that a getter returns something that's not immediate. But whatever, I'm not bothered. You know, I can handle this JavaScript. I can just put it in a separate function. I would just put it in an async function. So yes, probably what I would do is have something called like symbols getter, and have this be async, and then yes, something like const symbols is list of nodes, and then for const ut of list dots use traits symbols dot 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 ut dot nodes. Whatever. It's not something that particularly matter in terms of how it would work, and this would be await. Yeah. So that's the kind of expression that I would be thinking of having. So here, to work with the traits, I would want to have that kind of a structure. In fact, strictly speaking, strictly speaking, I would want to start with a resolver that will attempt to resolve the traits there and then. As in, sorry, I should clarify that. I should have a resolver which will attempt to resolve the traits before attempting to resolve any of the other symbols, because the resolution of the traits will naturally affect the resolution of some of the other symbols, because the other symbols will naturally refer to some of the traits. So here I've got the concept of a class body, and of course I won't have a separate concept of a class body. This will end up being something where I'm returning a value to go into the class, because I mean a separate class body isn't a concept that's necessary to carry around. So here I'm going to have an asynchronous set of symbols that get returned, and that's with the idea behind it that traits will be resolved before attempting to parse any of the symbols. If a trait can't be resolved, what I'll probably do is still return the symbols, but return them with an indication that their types are not known, where the type can't be inferred otherwise. So there'll be a slightly polymorphic behavior on that one. Okay, so that's the essence of what namespaces/class-like is supposed to be. That's going to be a thing where I deal with those kinds of symbols. It should be not parser. It should be namespaces. It's being consistent. This is a kind of an interesting problem in terms of how the import statement works. That you can have any old class name in here. It doesn't matter. It'll be imported in the way that the caller likes. So generally speaking, you can call it just by its file name or by like the full path to it. Um, Inevitably, I think this will end up being redefined as something a bit more specific, but for now it isn't. So we just have this as it is. Okay, I'm going to stop now, and then I'm going to resume and I'll talk about more about the kind of design I'm thinking of.